Dr. Emily Lowry, welcome to Podcastina.
Hi, thank you for having me.
Thank you so much for doing the show. I would love to just start with a very basic question for you. Can you please share what it is that microbiologists do?
Sure. So, microbiologists can do a whole range of things because microbes is just a very broad term. It's bacteria, fungi, viruses, which is a lot of different things. So, people can study how viruses infect us, they can study how bacteria infect us. They can also just study bacteria and viruses and fungi out in nature. Maybe someone's interested in mushrooms. I know some people who study soil bacteria, they're really interested in that. So it's very diverse.
That's so cool. And what is it about that field that drew you in, and how did you end up in the realm of studying cancer?
So I actually started off more in the cancer field and then learned about the microbiome, especially since I'm sure a lot of people are aware it's a really hot topic, both in research, health, and medicine, and just in the general public right now. And I got exposed to that a lot when I was in grad school, thought it was really cool, wasn't necessarily anticipating doing microbiome research, but it just kind of happened. And I ended up loving it. So that was kind of like a natural progression. Sometimes your interests just take you in random directions and you just got to follow them.
I love that. And what do you think, like, what are some of the biggest misconceptions about cancer research that were disproven to you through your work?
I don't know. I think a lot of the misconceptions are kind of at a surface level. Um, I think as I've learned more about cancer, I've realized how unique every individual's case is. No two tumors are the same. There's going to be different mutations. They're going to be in different locations. They're going to have different cell types present. They're going to have different factors influencing gene expression. So even the mutations aren't just the only thing contributing. It's really complex. And I think we're still trying to understand exactly how complex it is. So I think a lot of people don't realize that. And I wasn't even exposed to that much in undergrad.
Is it good or bad that it's so complex and different in everybody?
It's kind of bad. It makes it hard to treat. So I think a lot of the treatments try to, or a lot of the research and treatments try to find trends. So we know there are certain genes where we tend to see the same mutations over and over again, which means that's something we can try to target with a drug. And then we can treat more people with one drug.
Yeah, I think that that's kind of the sense that I got too, where I'm like, wait, maybe maybe it means people aren't doomed with a certain diagnosis because they're like, their particular situation is different, but it's very obvious how that would make it like so difficult to then find a cure that's going to be applicable to everybody.
Yeah. But I think that's also why there's a huge push for more personalized medicine and personalized treatments. We're not quite there yet, but that's definitely a direction that things are going.
It's such a heavy subject matter. Like, how did you end up in that area? What's it like working on something that, everybody is impacted by?
Um, I have been interested in cancer for a really long time. I don't really know what initially drove me to be interested in it. I think one of the first things was learning that our bodies already have so many checkpoints in place um, to make sure we don't get cancer. Like there are a lot of stopping points where cells will say, oh, hey, this doesn't seem right. So I'm just going to go die so that I don't give other cells this broken system. And so cancers have found ways around all of those checkpoints. It's kind of crazy. Like, I mean, this is terrible because it's cancer, but it's almost kind of beautiful how like smart these cells are. And I think that's one of the things that really drew me there. But it definitely, it has a bit of a disconnect when you're working on it because on one hand, it makes me excited. I get so excited by doing research and reading new papers and having new findings in the lab, but I'm getting excited about something that hurts basically everyone. Everyone is touched by cancer. And I am working at a cancer hospital. So I think seeing patients daily, doing fundraisers for patients, that kind of thing definitely kind of reins you in and realizes like we are really, yes, we love doing this research, but we're also doing it to genuinely help people.
Yeah, and it's such profound work, and that's great. And I mean, having to like be so inundated in it day in and day out, it's got to be heavy. But again, you're like working towards finding a solution for it. So maybe that's like taking away out of the heaviness. It's like it's our directive to find a cure.
Yeah. And I think fortunately for me, I'm hidden back on the lab side. I'm not on a clinical side where I see patients. So someone who's doing clinical research or who works as an oncologist, they're definitely going to probably see the harder side on a daily basis.
I'm curious about the, kind of cell having its own mind and being smart enough to die if there's like a cancer that happens. And correct me if I'm wrong because I have zero science background, but does that mean if like a cancer potentially started in someone, there's blockades within our bodies that get rid of it before it can be censored or sensed?
Yeah. So within each cell, say you have a mutation, there are certain machineries that go along your DNA and they try to make sure that it looks right. And if it says, oh, this, when it makes the two copies, this copy doesn't match that copy, that's not good. I'm going to activate a death pathway. And a lot of these systems are overlapping. So it's not like, oh, I have to have a very specific thing that happens to trigger this self death. There are a lot of different things that can trigger it. So that's interesting, but also kind of crazy that they overcome all of that.
Is it true that like if everyone were to live longer and didn't get taken out by other things, like if people lived into their 150s or 160, would we all eventually get cancer? Is the body just like meant to get it eventually?
So that's where, like, I personally find aging research really interesting because some of the um, attempts to help humans live longer also kind of go against our cells' normal, like, anti cancer processes. So, in figuring out how to help humans live longer, you almost have to solve the cancer problem. But definitely, as you get older, your cells are just not in as good of shape. You're more likely to get mutations. They're just under a little more stress. But then you think of people who live to be 115 and they're fine. So, again, that's where the aging people come in because they're very interested in why you have some people that are totally healthy and live so long. And maybe that could give insight into how not to get cancer.
Yeah, I hope they come up with something, but there's just way too many variables,
Oh, yeah.
Oh my gosh. What's like the most mind-blowing thing or most surprising thing that you learned about cancer?
um, I don't know. For me, the thing that I've already mentioned that I think is so crazy is just that these cells are able to bypass all of the checkpoints. It's crazy. Of course, there's some very niche things like there. It's a little controversial, but part of the field believes that there are bacteria present in tumors in humans. That's kind of crazy to think about. Like, why are bacteria there? How did they get there in the first place? So, but it's a little. Not everyone believes it.
What would it mean for that to be true?
um, A couple things. So one, it would be interesting. One of the things people look at is what kinds of bacteria are there, and are they kind of helping the tumor, or could they maybe help the immune system fight the tumor? So,
That's Monty.
but yeah, so it's kind of like goes different directions. And some people are even saying, oh, well, even if bacteria aren't present in the tumor, can we take advantage of the fact that they like living in tumors? Because the tumor is kind of like this cold, dark, low oxygen place, and the bacteria say, woo, this is great. There's no immune cells here. This is the perfect home. But if you take advantage of that, you can attach a drug to the bacteria. They're then going to go find the tumor, start growing and making their home there while also delivering an anti-cancer therapy. So that's one of the approaches that's come out of people thinking that bacteria are in tumors.
That would be so fascinating since we already have solutions for bacteria.
Yeah.
Wow. Oh my gosh. What is the truth behind the whole sugar and cancer thing? Because as I'm sure you've seen, as I've seen too, there's a lot of influencers talking about, and a lot of them have no credibility to even be in this discussion, but they're like, oh, just cut out sugar, it'll kill a tumor. Like, what, where is that coming from?
Yeah, I mean it's a pretty old concept. What is I think I forget the saying, but there's a saying with sugar like feed a tumor, starve a tumor, something like that. Um, the thing is, all of our cells need sugar. Like if you don't eat any sugars, your cells are going to be very unhappy and you are going to be like sick. Um, an interesting thing is that cancer cells use sugar a little differently than healthy cells. So they actually use it less efficiently. So you might think, oh, okay, so if you cut down on some sugar, your healthy cells will still manage, but the cancer cells won't. No, they start using other sources for energy. So they're actually fine. So if you reduce your sugar, you're not actually hurting the cancer cells. They just find other ways to survive. But one of the things that is true is that lots of added sugars is not good. So, like ice cream or like fruit juices where they throw in lots of extra sugars, those are not the best. So, those are always good in moderation, but cutting out carbs is not going to help. That's probably just going to make you feel pretty sick.
Yeah, and I feel like it would probably eventually, our bodies are super smart, right? The whole reason that the keto diet became a thing is that when your body stops using sugar and carbohydrates, it converts to using fat. So, in theory,
Yeah.
wouldn't cancer just do the exact same thing?
Yep. Yeah. They'll go to fats and proteins.
Which is, I mean, in theory, a nightmare because your body is fat and proteins, and then it would have like more of a source and more ability to, I guess, feed itself in theory.
Yeah. And breaking down fats and proteins for energy is a less efficient, like, biochemical process than breaking down carbohydrates. So it's just all around not good because it's less efficient.
Yeah, I can't believe people are. No, I don't want to sit here and say I can't believe people are spreading misinformation.
I mean, it
Welcome,
happens.
yeah, welcome to 2025.
Yeah.
Oh, it's just I'm trying to remember. I had like one more thing to say on the sugar and cancer front that is so fascinating. Oh, this point that the people that are kind of pushing that idea of, oh, just cut out sugar and just do this and just do that. I think when someone is at that stage where they're fighting cancer and their body is weak and they're going through chemotherapy or whatever other treatment that people understand like just absolutely ravages the body, at that point, shouldn't they just be getting calories any way that they can?
Yeah. I mean, I'm not a medical doctor, but definitely getting food is really important. Especially as you said, they're already suffering so much. And a lot of the traditional cancer therapies do harm all of your healthy cells too. So your body as a whole is just struggling. So you definitely, anything that helps, if you can get it down, it's better than nothing.
Exactly. How far are we from cures for like different types of cancers? I know there's no like one cure for all cancer,
Yeah.
but are we closer on some than others?
Um, I wouldn't say we're necessarily close to a standard cure. We definitely, because everyone's cancer is different, some people will be cancer free for decades from old school treatments, like chemotherapies that have been around for decades. But then someone with that same type of cancer might be resistant to every therapy we try. So it's very much on an individual basis, which is why one of the directions the field is going is more towards personalized treatments, where you would sequence the tumor, figure out, excuse me, figure out what mutations are contributing, see what you can target, and then create a custom therapy that's going to target that individual's tumor. And if we can get that kind of treatment working, the hope is that people would get less sick during treatment and they'd have better responses.
Are there certain cancers for which there's more routes to take?
That is something that I don't know. They're typically blood cancers are easier to treat, but not necessarily easier to cure. And that's just because your blood cancers are still individual cells. So it's just easier to hit them with drugs. Whereas a tumor, it almost is like a physical fortress. So it's hard to get anything to penetrate. And that's why those are harder to treat. So a lot of blood cancers have been more targetable. And then certain cancers have better mutations for us to target. Like pancreatic cancer, you a lot of people hear pancreatic cancer and they think, oh no, pancreatic cancer is really bad. And it's because we haven't found anything good to target it specifically. So it's really hard to treat. So there are some cancers where the treatments are pretty good. You can feel pretty optimistic if you get that diagnosis. Of course, no one's ever going to feel happy. But then others where we just haven't been able to make much progress.
Sorry, he's like freaking out. There's like a squirrel on the roof or something.
That's why I fed my dog before. I knew she'd be whining.
He always, Monty, can you please be good for like a couple of minutes? I beg of you. Anyway, that's okay. Luckily, I can cut the sound off my end.
Yeah.
Is there, I guess, because I don't really know like a ton about it, people are saying that we should be getting screened earlier for things like colon cancer. Do you know of like trends where that's rising and happening earlier for people?
Yeah, definitely for colon cancer, especially because it's increasing in younger people. So it's considered young if you're under the age of 50. And I believe screening starts at 50 in the US. It might be 45. It also depends on which organization you're going by, because different organizations will recommend different starting ages. And then some countries in Europe are actually going down to starting screening at 40 because of the increase in young cases. The problem is changes to recommendations are so slow. So it takes a while for the actual practice to catch up with what we're seeing in the real world. But then on the other hand, you see things like cervical cancer screenings. The starting age for that has actually gone up because of the success of the HPV vaccine. So it goes both ways, but I think colon cancer definitely is trending more towards earlier screening. Also, implementation of less invasive screening. So, using like you send out a poop sample in the mail and they'll tell you, oh, you have some things that don't look so good. Maybe you should go get a colonoscopy. I think that's going to get a little bit bigger in the near future.
That's good, the less invasive. I actually just learned just through my own like routine checkups that now you don't have to get pap smear done as a woman. It used to be like every year, and now they're like, you don't need it for several. I think they said 5 years. I was like, wow, that sounds crazy.
Yeah, and I think it used to start at 21 and now it's 25 because cervical cancer rates have gone down, which is great. They're also a huge area of research is trying to do just simple blood tests to tell you if you have cancer or if you are more likely to have cancer. That's a huge area of research because anything that's not invasive is a win, since people don't love going for a mammogram. They don't love going for a prostate exam. They don't want to get a colonoscopy. Just take some blood.
Yeah, it'd be nice if they could find more things like that. And then, especially with just how difficult and expensive it is to get like all the different scans and MRIs. And I mean, I'm guessing, is there just certain types of cancers that can only be found with that type of machinery or those types of tests?
I mean, any imaging, it's just easier to see, oh, that lump does not look like it should be there. Um, but of course, like a liver tumor, you're not going to go through routine screening to find that. They're probably going to wait until you have some symptoms that tell the doctor, oh, that might be cancer. And then they'll do imaging, blood work, that kind of thing.
So, we talked about a little bit how heavy this nature of work can be. How do you decompress after a day of work?
Well, I always come home to my very happy, excited dog. So that definitely makes a huge difference because I feel like as soon as I walk in the door, I just light up seeing her because she's so excited. Um, But otherwise, I have always liked hiking, but I've definitely gotten a lot more involved in different hiking organizations, which is just a really great outlet. Physical exercise. I even got, I had a gym in grad school with classes, and I made a group of friends there. We went to most of the classes every evening. We supported each other through milestones, whether they were an employee or a student. So I actually just joined a new gym. I'm hoping to kind of get a similar support system through that.
Such a healthy, great way of doing it. I love it.
I mean, there's also lots of binging TV,
Sure, we all do that too.
but
It's so strange being online these days, and I know like the current administration has a lot to do with this, so that's part of the answer to the question I'm about to ask. But science denial is insane right now. Like why do you think there's this like crazy war on science, and how do we begin to fight back?
it's so frustrating. Even today, I had multiple people comment on my social media basically saying that I should do my research before making these claims. And I was like, what do you mean? And then I was like, I did do my research. Here's what I read. Here's where I read it. Do with that what you will. um, yeah, it's definitely frustrating. And I don't expect anyone, if I say the sky is green, you shouldn't believe me just because I have a PhD. But I think people need to learn how to determine if someone's an accurate source. And I think a lot of the mistrust, there's always been mistrust in medicine and in science. I think COVID just blew it out of proportion because people lived through a time where science and medicine could not keep up with what was going on. And we were dealing with a new virus that didn't always behave how other viruses did. It made governments make these massive decisions. Everyone was just suddenly not following their normal daily routine and was forced to stay inside. There was so much fear. Some people wouldn't even bring groceries inside. And I think you had people go to kind of two different extremes. One of, oh my gosh, I need to be so careful. And another of, this can't be true. I'm just going to not listen to what people are saying and continue to live my life. And both populations continued to survive happily ever after. So you have this bias of, oh, well, I didn't take any precautions and I'm fine. So clearly what the doctors and scientists were saying wasn't true. Versus, oh, I took all these precautions and I'm fine. So what the doctors and scientists said is true. It's it's just hard when you have too many, it was almost like too many voices saying
Mm-hmm.
yes, no, do this, do that, panic. I don't know. It's really unfortunate what it did to public trust of professionals.
It's true, and it's almost like a deeper psychological problem. And I am in this camp too sometimes, where it's like it's very hard to hold two truths at once sometimes for us as people. And like the speed, I mean, that's such an important factor in this. The speed at which everything was happening and the fear that it was evoking in everybody. And I was in the camp of, Lysoling my groceries at one point. And then as we started to learn more, I think it became really hard for a large segment of people to be like, okay, yeah, there were some missteps in what happened with medical stuff and what happened with the science. And that doesn't mean you throw out everything, like you throw out the baby with the bathwater or whatever that saying is, where it's like, it
Yeah.
doesn't mean that everything is wrong.
Yeah. Even this week, we're seeing that the FDA removed the black box label on hormone replacement therapy, which had existed for, I think, more than 2 decades. And they basically traced it back to a poorly designed study. So it wasn't that the study was wrong. We just made assumptions outside of the range that that study applied to. And I think I'm not going to say people shouldn't trust science blindly, but I wish there was more forgiveness for when we make mistakes because that does happen. And it's not malicious, it's just that sometimes there are biases that you aren't aware of and you don't acknowledge them until later. but I feel like it's very important that we do check ourselves. And the peer review process is part of that. There are organizations that will go through and say, hey, we found this paper that we think is really influential. We're going to try to recreate it and see how much of our results match what these people found. There are whole groups that focus solely on that because we want to make sure that everything being put out there is accurate, but it's not always going to be. And I think the field does their best to make sure it is, but it isn't always.
Of course. And to speak to this phenomenon, what are the actual do's and don'ts of research from someone who works in a lab? Please share.
So, for someone who is just curious about learning more information, um, I think finding trustworthy sources is the biggest hurdle, but also the most important step. So, someone who isn't familiar with reading a scientific paper is not going to have fun trying to read a scientific paper. I had to read them for classes in undergrad and I hated it. Now I can just scan right over them and pick out what I need, but that's because I've read probably over 1,000 papers. Um, so I think finding university websites, hospital websites, government websites that will summarize studies, other research papers, tell you where the information came from, but break it down in simple terms. That's always a great resource. Like the Harvard School of Public Health, they have a lot of short articles breaking down different diseases, different medicines, like when you want to talk to a doctor. I love the Cleveland Clinic does that, Mayo Clinic, Healthline. There's all these websites that go through studies. They talk to medical professionals. They cite who they're talking to, so you can always look them up to make sure that they're actually like they have valid credentials. That's super important. I think numbers are really important. If you're going to look at a study that says, oh, we looked at 5 people and 2 of them got diabetes from drinking water. Well, that was only 5 people. So numbers are really important. And typically a study will say, oh, this was a small sample, so it might not be true. So I think always looking at the limitations, a lot of papers and scientists and doctors will say, here are limitations. So don't base future decisions off of this necessarily. The NIH also does a really great job of breaking stuff down. The CDC, they'll provide summaries and updates of our current perspectives and link you to where they got that information. So there are a lot of resources. You just have to know where to look. Doing a simple Google search, I mean, my Google searches are tailored towards someone who's Googling stuff about science. So I'm going to get a bunch of like journal articles, but a simple Google search won't always bring up the sources that you want. And I mean, a little hypocritical of me to say, don't trust TikTok when I'm trying to get people to trust me on TikTok. But I guess if I say something and I say, oh, it was in this paper or this person did this work, then maybe say, oh, I'm going to go look at that now. Primary sources. I think that's something a lot of people learned in school as a kid. If you're doing a research project for history, they would say, you have to have all primary sources. They would usually have rules of like, you can do one secondary source, which is, especially if you're getting older, it would be, oh, it's this person telling the story of what happened versus a primary source would be this person lived through it. So like an autobiography would be a primary source, that kind of thing.
Is there a way to circumvent a bad Google search by adding, like, oh, from this journal, or adding like certain verbiage that would pull up actual like peer reviewed science?
I usually actually do searches in Google Scholar, and that's going to turn up a lot different stuff than if you're just in the normal Google window. So Google Scholar is one of my favorites. People love using ChatGPT. I don't. I have some trust issues with AI, but if
You
for
should.
people who do use it, yeah, um, it provides links now, so you can say, "Hey, can you find me publications or articles that summarize this? I want a good explanation." It'll give you a little summary. It'll say, "Here are the sources. Go to those sources. See if what ChatGPT took out of it is matching up what's there." Also, there are some online journals that are now implementing an AI that basically turns the science talk into more lay terms. So it'll make it easier for you to read. That's a great resource.
That's terrific. Would you say is anecdotal research like pretty worthless?
I don't think so. It can drive really important research. Um, I actually this is kind of a funny story. Some people reported after getting their COVID mRNA vaccines that their tumors went away, which seems insane. And so that started as just, hey, doc, my tumor's gone. What happened? And researchers were like, huh, well, we've already been studying mRNA because those vaccines were actually being developed for cancer. And then they got kind of redirected towards let's do COVID vaccines during the pandemic. So they said, huh, maybe there's something going on here. And they actually found out that the mRNA triggers an immune response that then attacks the tumors. And it's an anti tumor specific immune response. So something that started off as just, hey, some people had tumors disappear, turned into this huge paper that came out just a couple weeks ago that could now possibly be a new treatment direction for cancer.
That's so cool. So then it's like you don't necessarily take it at face value, but the value of the anecdotal research is that it like opens the floodgates to doing grander research on certain things.
Yeah, especially since I mean, I'm trying to come up with a research project. That's really hard. So if you have someone come up to you and say, "Hey, I heard this thing or I saw this thing. It sounds kind of weird." And you can say, "Oh, I'll look into that. Let me find out why." That's actually a really great way of figuring out what's relevant.
That's so cool. What's it like for you working in a lab? What does your day look like?
It varies a lot. Right now, because I'm trying to come up with a project, I pretty much just read papers all day while I try to come up with ideas. I see what's been done, what hasn't been done. How would I answer the question I come up with from an experimental standpoint? But once I come up with that, my days are probably going to be a lot of experiments. Um, I will be working with cells. So, cells, you got to keep them alive. They're a little needy. They can't get too crowded and then they'll all die. So, it's like funny things like that. A lot of what you do on a day to day feels very silly and repetitive, but you do it a little bit different every day. And maybe you build upon stuff. So, oh, I have these cells. I want to try turning off this gene. Okay, so now I have to do a whole protocol to turn off that gene. And now I need to keep those cells happy. And oh, maybe I want to now measure something that's happening in the cells with and without this gene. So I'm just going to do a simple, like, look at the protein levels. It's all very simple protocols a lot of the time. And you just do it a million different ways. And somehow that all comes together in the end to give us what we like to say, it gives us a story. Our publications are us telling a story. So we definitely go through phases of lots of reading, lots of experiments, data analysis, which can be kind of tedious sometimes depending on what you're doing. In grad school, I spent maybe a quarter of my time on the computer doing computational analysis. If you're gearing up to write a grant proposal or a paper, you are just going to be sitting at your desk and writing, and that is all you're going to be doing. So sometimes it feels very repetitive, but it's not. And I'm the type of person who just loves being in a lab. So I'm happy to do whatever I can and just be around other people doing science, listening to their little struggles of, oh, my cells died. Now I got to start over.
Do you have any like front runners for where you think you're going to go with your research?
I really want to do something with immune cells in cancer, whether it's figuring out how to use the immune cells to attack the cancers or figuring out why are the cancers resistant to the immune cells, something in that area. It's been a huge area of focus for a while, but there's still so much to do, especially because you have so many different immune cell types and they all interact with each other.
That's really cool. I'm so excited to eventually read whatever it is
I
that you
know it'll be
find with
like
that.
10 years down the line.
As a scientist, what's the most frustrating part for you of this war on vaccines?
I think it's so frustrating because the mistrust in vaccines comes from a place of privilege. Like, we live in an era where so many devastating diseases have been mostly eradicated, if not totally eradicated, that we don't take them as seriously. You know, smallpox was horrible, and I believe smallpox was the first disease to be considered gone globally.
Mm.
Measles, what was considered eradicated in the US, it's borderline not anymore, which is really sad. And I think because, you know, I'm on the cusp of maybe half of people my age got chickenpox, half of people didn't. So I don't really remember people having it. So to me, it probably, I don't know. I don't remember how bad it was. So it couldn't have been that bad if I don't remember kids getting it. So I'm not going to bother giving it to my kid. I think that's kind of the mentality that's happening. But the problem is when you have all these diseases spreading more, it's a numbers game. So if 1 in 1,000 people have a serious complication and it used to be only 100 people got it a year, well, you're not really going to, every 10 years, you'll see that complication. Whereas now, if we're up to, 10,000 people per year are getting it, well, now 10 of them are going to have that complication. And that's just, it's not fair to them. And I think people just don't appreciate how serious all of these diseases are. Like, I don't know. I think if we could prevent every illness, we definitely would. We can't, but I don't know. I wonder if I don't develop vaccines, so I don't know if there's a mentality from infectious disease specialists of, oh, it's not worth developing a vaccine for that disease versus right now we're still trying to develop vaccines for bad diseases. Like, I don't know if we'll ever reach a point where doctors say, we're good. I don't know.
Well, if this backlash on vaccines keeps getting worse and worse, then all of those, the people studying the vaccines and creating new ones, they're probably going to have to go back to the drawing board because things like polio and measles could potentially end up like mutating. And then the original vaccines that we've had for decades are not going to work anymore.
Yep. Yeah. It could be something like the flu or COVID where they mutate so fast. So we have to do a new vaccine every year.
It's again just part of the frustration around the misinformation. And it's like,
Yeah.
if it ain't broke, don't fix it. Like, why are we going after the polio vaccine right now?
I know.
Like, come on.
I had a roommate who had never heard of polio.
Good for
And I was
her.
like, we had a president. We had a president who was paralyzed because of polio. Didn't you learn about that and how he hid it by like adapting his desk to hide his wheelchair? Like, that was in history class.
Kind of on that same subject matter, are there like health trends that you're seeing online that you're like, why are we doing this?
I mean, for the most part, so many of them are harmless. I only think it's ridiculous when people are spending lots of money to do things that, as far as we know, have no benefit. That's silly. And I get frustrated when wellness trends are promoted over actual treatment. So you're just making yourself suffer unnecessarily. A lot of people promote lifestyle changes for treating autoimmune diseases, claiming that they cured their autoimmune disease. That's not going to happen. As far as I know, there are no cures for autoimmune diseases just because of the nature. It's kind of like cancer where something has gone rogue. So you have checkpoints when your immune cells are developing, and for some reason, a cell gets past that checkpoint, and instead of targeting something foreign, it now targets you. And unless you want to just kill all of the immune cells in your body, you can't really treat it. So, yeah, I think the other than the unnecessary suffering, another time when it can get potentially dangerous is with supplements because it's not a regulated industry. And again, for the most part, they're harmless, but there have been studies showing that because a lot of these supplement manufacturers aren't actually checking that what they're producing is what they say they're producing. Like, you could say, oh, I'm going to go buy this calcium supplement, but it might not actually be calcium in the bottle. It could be something else. And there's no one checking that. So some of the larger companies will do that checking themselves. So that's one thing people should do, is definitely go and check the brand of supplement they buy, to make sure that that company is doing testing to make sure that they're producing what they say they are. Those are safe. And some things, anything in excess is bad. Like you can kill yourself from drinking too much water. So some of the supplements in the doses people are taking them can be dangerous and can cause organ damage. And I wish that was a little more widespread, because a lot of people say, oh, it's natural, so it's safe. But that's not always true. I mean, alcohol is natural, and alcohol is definitely not safe in
Yeah.
excess. So,
Yeah, that's such a good point. And the supplements thing, it's so interesting because a lot of people will just buy into the hype of whatever supplement is trending at the moment without even necessarily knowing if that's going to be beneficial for their bodies, let alone if the supplement itself is legitimate.
yeah. Yeah. And that's not to say that supplements are bad. It's just, I think because it's not regulated, you have to do a little more of the legwork yourself to make sure that you're getting something safe.
Yeah, absolutely. Speaking to weird trends, and this goes right into what you work on in the lab as well. Why are people so obsessed with the microbiome right now? What is that?
I mean, from a research standpoint, it's super trendy right now.
Hmm.
Like, super trendy. And it has been for a while, and it probably will continue to be for a while. And that's because we know nothing. So there's so much to learn. So it's actually, it's really easy to come up with new projects that no one's done. Like, you don't really have to try that hard. Um, which was great when I was in grad school. I could just ask a question, and odds are no one had thought of it, and I could just go do it. Um, so I think because we're doing a lot of more observation studies in populations, like, oh, people who have this bacteria tend to have asthma or tend to have diabetes. We're getting a lot of those studies, and people find that really interesting. Like the general public, they'll say, oh, wait, should I change my diet so that I'm not going to get asthma, or I'm not going to get diabetes or depression? But we don't actually know the strength of that effect. And we don't know, that's a perfect example of correlation does not equal causation. So we've seen this trend, but we don't know, is there a cause? Is it that you see those bacteria because there's something about that person's body that makes it a nice environment for that bacteria? Or maybe those bacteria prevent some other bacteria that help prevent asthma. It can get so complex, and we know almost nothing. So I am so happy that people love the microbiome, but on social media I get so frustrated too, because people love to overstate connections. And there's this whole idea that if you aren't a very healthy person, your gut is probably not healthy. And that's just not true. Like, the only reason your gut wouldn't be healthy for the most part is, okay, you've just done a round of antibiotics. Yeah, your gut microbiome is going to be pretty messed up, but it's going to recover. And you can do things to help it, but you don't have to. Or people who have inflammatory or autoimmune diseases related to their intestines, they're also going to have kind of a dysregulated gut microbiome. And that's not the cause of their disease, it's more a symptom of it, which is another thing people like to switch up.
Yeah, there's a lot of, is it the chicken or the egg? Like, do I have all
Yeah.
these issues because of my gut microbiome? Like, there's such an
Yeah.
obsession with that. Is it not really connected to literally every other part of our body the way that people say it is?
I mean, it probably is. There's like I said, there's all these observations. We just don't really know the why yet, and that's we have to figure that out, and that's going to take a while, especially since another point I like to make is that our technology and affordability of that technology hasn't quite caught up to what we want to do with the microbiome. So it's actually really hard in a lab for us to confidently identify the bacteria in someone's gut.
Oh,
Yeah, because right now, think about E. coli. You hear, oh, I was sick, I had E. coli. E. coli can cause really bad food poisoning, can make you really sick. E. coli is also naturally in your gut. So it can be good and bad. And that's because there's different strains of E. coli, and some are really bad, and some are totally normal and healthy. And they look really similar. So when you just take, right now, what you do is you sequence one gene, a part of one gene, and then map it back to references that we have in databases, but that gene might not be different enough between all, like a good strain and a bad strain. It might not even be different enough between two species. But it's too expensive for us to say we're going to sequence every single bacteria, the whole genome. That's way too expensive and just a lot of work from like a lab perspective and a computer perspective. So that's another kind of disconnect. A lot of the papers that publish, as someone who has like been in a lab that does this, they definitely overstate the confidence sometimes of what they've identified. But I think it's great that people are very excited about the microbiome and its connection to health. I think the best thing to do is just live a healthy life, and that's going to support a good microbiome. And I definitely feel sad as someone who thinks the gut microbiome is so interesting. I hate that people blame it for everything. They're like, oh, it's your microbiome's fault that you have allergies or you're depressed. Like, no, it's not. I mean, it might be, but it's not the only thing. Like, there's other stuff causing it. Stop blaming the microbiome for all of your problems.
And the things that are being sold to us as like fixes, are they mostly BS? Something like sea moss or like I mean, I know probiotics are legit, but like the weird trendy eat this, it'll fix it thing.
Yeah, I think what is it? People, I don't know if this is for your gut, but people like to have bone broth.
Yes.
And I think, and like hot water with lemon, I think that's a thing. I mean, they aren't bad. I just don't know that they're doing as much as you might think. The big thing is fiber. And that's, I mean, that's really trendy on social media right now, is eating more fiber. And that is true, because fiber is the primary food source for your gut bacteria. Actually, if you take antibiotics, fiber helps recover your gut really well. Probiotics, it's kind of like iffy on them because a lot of the bacteria in the probiotic get killed in your stomach because they have to go through the stomach, which is super acidic. So that's one limitation. And that's why the fiber is still getting through your stomach and it gets processed in your intestines. So you actually end up feeding the bacteria there and helping them just be happier. So that's probably one of the easiest and most direct ways to help overall gut health.
That's super helpful. I'm so glad that you shared that. Thank you.
Yeah. Although the one thing is, I haven't experienced this, but if you don't eat a very high fiber diet and you suddenly throw in lots of fiber supplements, you are not going to feel great. You got to do it slowly.
That makes sense for reasons that we will leave up to people's
Yep.
imaginations in case anyone is eating or doing something sensitive while they're listening to this.
Yeah.
People, that's such a good point, actually, though, that the things that are being fed into our stomach are like this barrier. It's kind of like a security guard before things actually get in there, because I'm sure you've seen this too. People will try to sell you on like alkaline water or these different weird systems that are like thousands of dollars, where I'm like, that's not getting past the stomach and doing anything effective.
Yeah. The whole water thing is really confusing to me, but especially since having things in your water is good. Like having different minerals is good. It actually, that's why electrolytes are good, because our body is this whole system. I mean, everyone learns about osmosis and diffusion, and your whole body is just doing osmosis all the time. And you need ions, which are your minerals or electrolytes, and you need water to do that. So you need to have both, which is why if you have too much water, you die because you basically flood your system and everything stops working. So it's all about a balance there. So dealing with pH, like the whole pH thing, I forget specifically what it is, but I was reading one thing about it because I was curious, like, what does it even mean to be drinking alkaline water? Pure water is a perfectly neutral pH. Also, our bodies, I forget our actual pH, but it's basically what water is. So our general pH. So it doesn't
It's in
make
a very
sense.
tight range. Yeah.
Yeah, it doesn't make sense to drink something that's outside of that.
What bad health advice have you heard that people need to steer clear of?
Oh, there's so much. um, One of the things, this only applies to people with cancer, but I've seen people say that chemo doesn't work, or not that it doesn't work, but that it's only making you sicker. And that's something I get very frustrated about because, yes, chemo does make you sick. And that's because a lot of chemo targets fast growing cells. So cancer cells grow really fast. Our regular cells are not going to grow that fast, but they're still growing. So a chemotherapy is still going to hurt your healthy cells. So you are going to feel sick. If you get radiation, I mean, radiation is not good. We know that. You're just not going to feel well. Even the targeted therapies that hopefully are only killing the tumor, it's like any drug, you have side effects. And I think a lot of people misinterpret the whole treatment process where you do have to get sicker before you can get better. And that's counterintuitive to a lot of other things. Like, oh, I have strep throat. Well, within 24 hours of taking antibiotics, I'm going to feel like $1,000,000. It's very different from kind of a traditional experience with medicine. And I get very frustrated when people say, no, don't do chemo. It's bad. It's going to make you sicker, which it will, but it's helping you. And of course, that's every individual's choice. But I want them to have the right information when they make that choice.
Absolutely, because I feel like a lot of times the people who say don't do chemo are in the same camp of the people that are going to turn around and try to sell you an unregulated supplement to help you with your cancer instead.
Yes. Yeah. Also, probably the same people that claim that getting a biopsy is bad because they believe that cancers are formed out of trauma and that it's
Oh,
like
I
our
haven't
body's
heard
way of
that.
telling us that we have trauma and that if we like heal our mental state, we can heal our cancer. But that by getting a biopsy, it releases all these toxins that make it worse, which is just not true. People even did check. They're like, okay, if we do a biopsy, are we releasing cancer cells and causing metastasis? And the answer is no. They checked because that's a legitimate concern. Doctors and scientists checked and they were like, nope, we are not causing more cancer to spread by doing biopsies. So it's definitely not the thing.
Good, it's been put to rest officially,
Yes.
officially. Amazing. What is next for you?
Well, right now I just started a new job, so I will be there for a while. Hopefully continuing to kind of document life as a scientist in our ever-changing health and political realm um, on my TikTok, Microbiome Talk. But yeah, I'm just going to hopefully continue to grow myself within cancer and maybe more microbiome research while also just kind of continuing to promote science communication.
Amazing. Well, Dr. Emily Lowry, if people want to support what you're doing, where should they go?
You can check out Microbiome Talk on TikTok, um, or my papers are on Google Scholar if you want to be ambitious. But I've also talked about them on my TikTok in more understandable words.
Amazing. Well, thank you so much for all the work that you're putting out into the world. And thank you so much for coming to talk to me more about it.
Yeah, thank you for having me. I was really excited to talk about all of this.
Me too. And thank you, everybody, for listening. Bye.